Hey guys, I wanted to go over our Matter Unit Study Guide. Today for our Zoom lesson, we just went over our study guide quickly and then we did our Matter Breakout digital review in our digital breakout groups this afternoon. So I couldn't really record that, but this is the unit study guide. So what is Matter? Most of this we went over yesterday in Zoom and through our slide practice. So matter is anything that has mass and takes up space. So anything that has mass and takes up space is matter. Okay? That's the definition of matter. So then it says draw a picture to represent the molecules in a solid, liquid, and gas. So a solid has definite shape and volume. And I like to draw a block. So you just draw a square, and you can draw any solid. That will work. But I like to draw, or we need to draw the molecules. So inside of a solid, you have molecules that are packed closely together. The solid has a definite shape. It's not going to change its shape. It has a definite volume. Its volume doesn't change unless you're changing its state of matter. Definite shape, definite volume, that's a solid. A liquid has a definite volume, but it takes the shape of its container. So if we drew a cup, and I had water or juice in my cup, the molecules would definitely be, they're packed in there, but they're more free-flowing. They're not packed all very tightly together like the molecules in a solid. Okay, so if I poured it into this pan here, or this cup here, and then I poured that same water into a cup that was tall and skinny, it is going to spread out and be tall and skinny. So it takes the shape of its container. In a gas, it has no definite shape or volume. So I like to draw a balloon, and it expands, the molecules expand, they spread out to take the shape of its entire container. It has no definite shape or volume. It's going to fill up any container that it's in. So that's a solid, liquid, and gas. So this is describe the changes in forms of matter taking place. So first we have evaporation. Evaporation happens when you have a liquid and it changes to a gas, like water, evaporating and changing to water vapor. And this happens when heat is added. So if I add heat, I warm up the water, it's going to evaporate and change into a gas called water vapor. Condensation is where we would take that gas, water vapor, and it would change back into a liquid. And this happens when heat is removed. So if I take heat away, that means I cool something down, I remove its heat energy, and the particles start to slow down and they start to come together, and the gas molecules will come together as they get cooler and cooler and cooler, and it will eventually turn into a liquid with something that has more definite volume and shape than the gas. So I take the heat away, I cool it off, and you have condensation, which is gas to a liquid. Freezing is where I have my liquid, like water or juice, and it changes to a solid. And I do that by removing heat. Okay, so same thing. Heat is removed, it gets colder. Removing heat, it freezes. If I put water in the freezer, it freezes. Melting is when you have a solid, like ice, and it changes to a liquid. And that happens when you add heat. You add heat, you warm something up, the molecules start to move faster, speed up and spread out, and eventually that solid where all the molecules were packed very tightly together become a liquid. So the solid changes into a liquid, and that is melting. All right, so down here we're reviewing a physical change and a chemical change. So physical change is when a material undergoes a change without a change in substance. So that's when it can be easily reversed. I'm going to add that here. So here we have easily reversed. And then a chemical change is when a material undergoes a change that creates a change in substance. So something new is created. Like if you burn wood, it turns to smoke and ash. The smoke and ash weren't there before, something new is created. Or also the chemical change is irreversible. So remember, we talked about once you bake a cake, you can't get the ingredients back out because they've turned into something new, cake. Once you burn paper, it's turned into a new substance, ash and smoke, and you cannot get that original wood back. It's irreversible. It cannot be changed back. All right, so physical change or chemical change. Matter changing states. Okay, so this is always the one that fifth graders get confused about. Changing states, that means from a solid to a liquid to a gas. When I change states of matter, I can reverse it by adding or moving heat. So that is a physical change. Ice melting, water freezing, evaporation, condensation, all those things we were talking about up here, changing states of matter, that is a physical change. All right, iron rusting on a bicycle, that's a chemical change. You cannot unrust something. Now you can scrape the flakes of rust off, but once that metal has rusted and turned into rust, that is a chemical change. It's a new substance. A strawberry is cut in half. That's a physical change. It is still a strawberry. Didn't create anything new. A piece of cardboard board burned. That's a chemical change. Anytime you burn something, that's going to be a chemical change. Baking a cake is a chemical change. We've talked a lot about that in class. Water freezing into ice. All right, freezing. That's one of those words that we had up here in our chart. That's where a new, you have a change in form or a change in state. So I can unfreeze water. If I freeze it and it turns into ice, I can melt it and it'll turn back into water. And that is going to be a physical change. You didn't create anything new. It's easily reversed. Add or remove heat. Copper melting is a physical change. It's still copper. Okay, we talked about that yesterday through Zoom. We were talking about a welder. They can heat up the metal and mold it into what they need to mold it into. All right, so here it says draw a picture of a physical and chemical change not listed. So you're thinking of one that's not listed on your chart, right? And that can be anything as long as it is a physical or a chemical change. All right, let's go over the questions on the back. There are just a few. All right, so remember, substances will only change mass if matter is added or removed. So if I don't add or remove anything, the matter, or if I don't add or remove any matter, the mass is going to remain the same. All right, so remember, the total mass of an item is the sum of all its parts. So if I have a block tower, so let's say I stack a tower up of blocks. If the block tower is 5 grams, and then I knock the block tower down, got 4 blocks, let me make sure I get my 4 blocks, and I weigh this 5 grams, and then I weigh this, it's also going to be 5 grams. I didn't take anything away, I just knocked my block tower over. So if I don't add or remove anything, it's going to stay the same. All right, Josh cuts a 1-pound block of cheese into 4 slices. What is the weight of the cheese after? All right, so here's my cheese, and I cut it into 4 slices. It was 1 pound. It's still 1 pound. I didn't take anything away. I didn't add anything to it. Still 1 pound. All right, ice cream is made using 30 grams of sugar, 250 grams of milk, and 10 grams of vanilla. What is the total weight? So here we have 30 grams of sugar. So I'm going to take my 30 grams. I'm going to put it with 250 grams. Okay, and then I also have 10 grams. So I've got to put all those together to find the total. I'm going to come over here and add those together. So I've got room. 250, excuse me, 30 and 10. 290 total grams. I added things together here, so it is going to change. My mass changes, it increases. All right, mulch is made by crushing tree branches. If 10 kilograms of mulch, and here you shouldn't need to add a word or a phrase here. If 10 kilograms of mulch was made, so we crushed the tree branches, we made the mulch, how much tree branches were used? And this should say how many kilograms of tree branches were used. So this one's kind of worded a little bit differently. But guys, if you used 10, or you got out 10 kilograms of mulch, you used 10 kilograms of tree branches. Okay, so whatever all you're doing with mulch is you're chopping it up. It is taking a tree branch and cutting it into smaller pieces, crushing the tree branch. If I made 10 kilograms of mulch, I started with 10 kilograms of a tree branch. Nothing was added or taken away. We just physically changed it. All right, a piece of paper is 8 grams. It is torn into 4 equal sections. When weighed together, how much does it weigh? So, you have your paper. The total is 8 grams. You're going to tear it into 4 equal groups. You're going to weigh all the parts, and it's still going to be 8 grams because I didn't take anything away and I did not add anything to it. Don't overthink these questions. If you didn't add anything, it stays the same. You didn't take anything away, the mass will be the same. All right, explain. You heat a pot of water to its boiling point. That's a clue. You're heating it, it's boiling. If you found the mass of the water before boiling and after boiling, would the mass be the same, more, or less? All right, so here I've got my pot. I always like to draw a picture. I'm a very visual learner. If I can see it, it helps me figure things out. So I've got my burner and I've got my pot of water. So here's my mass. I weighed it here. So then I've got another pot, and the difference in this pot, or this picture, is the water is boiling. So I've got some bubbles going on here, and you've got your water turning into water vapor, evaporating, and then you've got steam rising here. Here you've got evaporated water. You have evaporation going on. We know this happens because we see it all the time when we're cooking. So you have water escaping in the form of a gas into the atmosphere. So eventually, if I left this pot of water on the stove, my water level is going to go down. It's going to decrease because I've got water evaporating and changing into a gas. So this is going to be less. It's losing mass. The water is changing into water vapor. So I'm losing mass here. So we would find that the mass is going to be less. The mass is going to decrease. So let me write that out. So the mass will decrease because the water is evaporating. All right, so that's a quick review of your study guide. Make sure you look over everything and be prepared to apply all of your knowledge in science to your science unit test on SchoolNet tomorrow. I can't wait to see all of the things you've learned in this matter unit. And let me know if you have any questions before you take the test. Don't take it because I can't, once you take it on SchoolNet, I can't, send it back to you. Once you take it, it's taken. I have to create a whole nother test. So ask now, take your time, read carefully. Let's do a great job.